Hello, I'm George Flew, and I'm the creator of the 3DUtility toolbox. In one of my previous videos, in connecting up this transformer on the low side, I took a shortcut and used 1000 MCM copper. I've had a little feedback on that, and so I decided I'd come back and rectify that. So let's just quickly go and look at our design data. 182430 MVA transformer at 12 kV is going to have a low side ampacity or current requirement of about 1500 amps per phase, which says that we need to actually use two 750 MCM coppers, not one 1000 doesn't quite cut it. So we're going to quickly come in here and try to fix this problem. So first thing we're going to do is come in here, pull up our form, and we're going to put in a coupler. It's a tube to flat coupler, and this one is a 2.5 inch bus we put in originally. This is similar to a tube to flat terminal, except this was made to couple to go on to continue on. So we'll insert that here at the on that node point. Quickly we'll copy that to these other two buses. Then to that we need to add, so to connect here, there is no direct connection available for a tube to a two conductor. So to that one we need to add a terminal that would be conductor to flat, and here you'll see we've got a 2 times 500 to 2000 MCM. So that's this double barrel looking connector here. So again, we're going to keep it on node, do an insert. We're going to insert this once, and we're going to copy it a number of times. We'll copy it here. We're going to go ahead and copy it to this side. Let me take that off so that it looks better. Copy it to here. Copy it to here. We're going to need it over here on these switches. And then I'm going to drop one right here, and we'll cancel. We'll go in here and we will rotate that one twice in the Z-axis. Then we'll copy again. We'll probably corner the market on these connectors, so there's many of them out there. Okay, so now that we have all our connectors on there, before we begin, we need to go over here to our layer and insert a new layer. Come down here under this layer name and put the new X bus 750 copper. Come over and change the color to red. And now we've got and let's go ahead and set that as our current layer. And then now we're ready to come in here and start laying in our jumpers. And be careful, there's a lot of nodes here. Easy to hit the wrong one. Just a matter of getting them all in, just a matter of time. Okay, now we need to come over here and at our transformer. First thing before we start, we've got our connectors here. That one somehow missed the mark. Drag it back into Tennessee there. Orienting our connectors down here is going to be important. So what I'm going to do, let me just go down here. I'm going to pick these 3 spade connectors on this transformer. I didn't get that one on the transformer bushings. I'm going to go up here and rotate them one time in the Z-axis. And so, as we've said before, you can if you select some blocks, then you can actually rotate them or copy them or whatever. But if you don't select them, it uses the last one. Well, we selected these. Now, if I wanted to rotate them again, I'd have to select them one more time, because unfortunately, the way AutoCAD works here, it doesn't keep selecting them. And so now, I need to put my connectors on here. We're going to go down and turn our dynamic UCS on and do an insert. We still have it on our node point. It's going to come down here, and it's going to, we're going to find, yes, we're going to find that face, and it's going to orient correctly. And we're ignoring the neutral. I guess you realized that before. So now we've got the connectors there, and you can see while we turn these 90 degrees, we want these conductors to be parallel when we run these jumpers. Oh, I think I had that one selected a while ago when I did the undo. See if we can't get this one to rotate without the other one rotating. No. Okay. Now we got that one rotated back right. Now let's go back in, and again we go to our jumper command. I got the, yeah, right half of the double barrel. Okay, now we've got our conductors, jumpers laid in here. We've got one final task. So you see these jumpers come down in this kind of an arc. They're susceptible to sagging, especially under conditions like ice loading. So we would like to stiffen up this this whole mechanical system here. And then also with wind, you can get vibration that will cause RFI. So we can solve both of those problems by going over here and selecting our spacer, our spacer connector. Here you can see connector, spacer, cable to cable, copper, 750 to 1000 MCM. And as all of our connectors are, it's oriented in the x-axis, which is, as you can see, the first part of these jumpers are oriented in the x-axis, but obviously as we get down here, these are not. So what we're going to have to do here is jump into something I've been talking around in my previous videos, and that's the UCS. So let's come in here. So what we need to do is we need to realign the UCS to align with this conductor, and we do that with the UCS command, Universal Coordinate System. And the first option on there, we've got a lot of options, but the default is to pick a point, a new origin point. And the next option is to pick a point on the x-axis. So I'm going to come down here and pick a point on that, another point on that line, and the third option is pick a point on the XY plane. So I'm going to type in perpendicular and make sure I find a point over here perpendicular that's in line with this other conductor. So here you see my x-axis, my y-axis is across, my z-axis is going out somewhere in front of your nose. So at this point we can go back here and let's take the node off, and let's leave the near snap on, and we'll do an insert. And we'll go down here somewhere. We want to be somewhere just past this the edge of this arc, and we put that in. And if we zoom in there, you can see then that we've accomplished that. Then we can do a simple copy this down. We want to get it somewhere down here close to this next arc. And so we've done that. Unfortunately, we can't copy over here because each one of these lines is in its own plane. So we'll do a cancel. We'll go back to the UCS command. We'll pick a point on the line, pick a second point down here on the line, pick a perpendicular, and then insert, then simple copy. Okay, and then go over here to the, excuse me, trying to pan, go over here to this third line, do a UCS, pick a point here, perpendicular, and then insert, and do a copy. And okay, there we have our spacers on our transformer jumper. We probably don't need them here. This is so short, the vibration is not a problem, certainly the mechanical part. Here, maybe the wind vibration may be a problem here. So let's go in here and put them here. Let's put our UCS back to the world, and you can see here, type in UCS, and then the default, if I hit enter, is world. Now, these may not be exactly in the world coordinate system. They're awful close. I'm going with awful close, and then I'm going to take and put the mid O snap on here, so that it will assure I put this at the middle of that conductor. And you see that little green triangle indicates that's the midpoint. And then I'm just going to simply copy it across. Be sure I hit the right pair of conductors. And so now there you go. Now we have our parallel jumpers that meet our design requirements of 1500 amps per phase. And so I hope this will satisfy anyone that had any concern. And so with that, we'll wrap this one up, and just remind you that if you'd like to send me a comment or ask me a question, you can go to the3DUtility.com, and at the top right, click on the contact on the menu, and be sure and include your email if you want to reply. And so we'll call that it for this one, and keep checking back. I may be adding some more. Thank you.